Hey, I thought today I would continue working on the MIT integration bee from 2022. This was regular season problem number 7. We have the integral of dx over sine to the fourth x times cosine to the fourth x. We could approach this a few different ways, but I think what I want to do is use the double angle formula for sine. So let's take a look at that real quick. Okay, so we have this formula over here to the right, and I think what I'll do just to get it a little bit more into this form, if I divide by a 2 on both sides, we can write this as sine x times cosine x equals 1/2 sine 2x. Now our denominator here, we could write this as sine x times cosine x all to the fourth. So if I raise this to the fourth, let's see what we have. So using this raised to the fourth, we can write this as sine 2x to the fourth. Then we can write a 2 in the denominator raised to the fourth. This is the same as, so this is going to be the same thing as sine to the fourth 2x over 16. So now using this, if I just rewrite my integral, okay, we'll write in the denominator sine to the fourth 2x. But instead of putting the 16 here, I'm going to flip it to the numerator and bring it out front. So we're going to have 16 out front. But now because we have a sine in the denominator, we can write this in terms of cosecant. So I can write this like cosecant to the fourth 2x dx. And then this cosecant to the fourth, what I'll do is I'm just going to split this up and write it as cosecant squared 2x times cosecant squared 2x dx. Okay, now next I'm going to use an identity to transform this to try to set up a u substitution. Okay, so we're all familiar with this identity, sine squared plus cosine squared equals 1. Now if I just divide by sine squared on both sides, this is going to give us, dividing the sine squares, we're going to have 1 plus, this is cotangent squared x equals cosecant squared x. So what that's going to do is give me this value to use to plug in right here for cosecant, except remember except our angle here is 2x, so I'm going to rewrite this using our formula here. So we're going to have 1 plus cotangent squared 2x times cosecant squared 2x dx. And then from here, I think we're ready to look at a u substitution. For my u, I'm going to call my u equal to cotangent x. And so taking the derivative du, this is going to be minus cosecant squared 2x. Chain rule, we need to pull a 2 out, so we'll squeeze that in right there. And what I'm trying to do, I want to have my du right here. So what I'm going to do is kind of force this to happen. I'm going to multiply a minus 2 in right there, but then I need to do the same thing out here, so I'm not changing it. And then this is our du. So now we'll make the substitution. 16 divided by minus 2 is going to be minus 8 out front. We're going to have 1 plus, this is our u, so we're going to have 1 plus u squared, and all this is our du. Then we'll just integrate this thing. We're going to have integral 1 is u, integral here is going to be u cubed over 3 plus c. Sorry, typo, there's supposed to be a 2 right here, cotangent 2x. So now we'll just back substitute to finish it off. So for our final solution, we're going to have minus 8, u is cotangent 2x plus cotangent cubed 2x over 3 plus c, and we're done. Okay, that's it. Pretty good problem today. We'll stop it there. Thanks everyone for watching. Have a great day.